We've actually had a little preview into this, but now let's talk about the purpose, content, and function of a collection so we can see how we can use this in large form within our solutions. So, for the most part, at this level, when we've wanted to store more than one of an object, we've typically used an array. The array allows us to have some sort of predefined number of objects and gives us some nice functionality. We can store more than one, but that's super flexible functionality. I mean, what if we want a dynamic number or the ability to do interesting features within what's available inside of a typical array? And so let's get into kind of what this is. The idea of a collection is instead of, let's say we're having a dinner party. Dinner party, we sit out 8 seats. There's me and 7 other people that are going to be there. Well, if I invite somebody else, what happens? I have to kind of rearrange everything. I have to get a new seat, put it down, find a new space, reset the table. Gosh, now it's uneven. Well, what if I had somebody else? Okay, well, add another, so on and so forth. It's a lot of manual work anytime I add somebody new to my dinner party. Well, this is software. And yes, some manual work needs to happen, but there's ways we can automate that work, where a collection at its heart allows us to create a dynamic storage mechanism where I don't need to know how many seats there are going to be at my table up front. I just say, hey, let's just start adding people in, and add people in, add people in, add people in. And at some point then, we just expand out the storage based off of how big it ends up being. If we have 10 people, 20 people, 100 people, 1,000 people, it all just keeps growing. And there's some other nice features we get along the way too. So the whole point of a collection is I no longer am stuck with having to track things by an index, 1, 2, 3, 4, 5, like I do in an array. I can add a whole bunch of stuff. I can clear a bunch of stuff. I can add stuff in the middle, at the end, just inserting things or anything. And all I have to do is use some predefined methods to make that happen. So inside of a collection, you can see I can add one thing, I can add a bunch of things from another collection or whatnot. I can clear out a collection, wipe it all out. I can iterate through them one at a time. So instead of having to index 1, 2, 3, 4, 5, it'll say I start with the second one, the first one, then go to the next one, go to the second one. I can remove things from a collection or remove everything from a collection. And when I say remove everything, it's different than clearing. I can say there's 3 things, take these 3 things out of the collection. Take them out so I don't see them anymore. You can ask for its size, and then you can always turn it back into an array. Now, when we say collection, this is a general set of functionality, but there's more to it than just this general set of functionality. There's actually different types of collections that allow me even more features or limitations or capabilities that I want to based off of what I'm saying. So the collection hierarchy gives us a couple branches. Sets and lists is the first branches out there, and then kind of separate from that is the idea of a map. We'll talk about these at a high level, and then we'll get into these in more detail in future videos. So at a high level, you can see the set and list are both a shared type of collection. I can add items in, I can take items out, but then there's more detail about them. A list is pretty much what we're used to thinking of. We put items in, there's a bunch of items in. A set is similar, but allows us only one copy of each item inside of it. That's what we're going to see there. And a map is a really cool key value pair that we're going to see here in a second. Each of these are realized through the power of interfaces. A collection is actually not an implementation at all. It's an interface. List and set are interfaces. It's not until you get to these bottom items inside of here, vector, linked list, array list, stack, tree set, hash set, these are the items that I actually have implementations, that I actually have all the details. But the great part about this is I can switch back and forth. I can work with any of these. You can hand me a list of items, you can hand me a set of items. I can walk through each one of them one at a time and do whatever logic I need to do within my code. So lists, sets, and maps at the high level all allow us to add and store groups of items. The key thing about a list is they're added in order. Duplicates are allowed, but I keep track of the order. Think of it as kind of like a library checkout list. I just add people in, and whoever comes first, I get on the list first. Whoever comes second gets on the list second, so on and so forth. A set, think of it as like an invitation to a dinner party. I don't want to invite the same person twice. I don't want to take up the seat. So I go through the list and make sure there's no duplicates. I make sure it's off of that. Where at the same time, a list, list for reservations, maybe I do want to eat and then come back and eat again. That's okay. And then a map, as we said, is key value pairs. So lists and sets are very similar. They're very interchangeable in most of the grouping mechanisms. Sets don't typically have any order associated with them because of the way they're stored, but lists do. Maps, again, they're very, very useful. We won't get to play with them much, but they are a completely different part of this hierarchy. So looking at these, if we look at just the way of thinking about a basic collection, and it's important to distinguish each of these three, a collection is often referred to as a bag. So you think about when you're playing Scrabble. There's a bunch of tiles inside of a bag. I reach in, I grab one out, and it's completely random which one I grab it out. It's not necessarily the first one that went in the bag. It's not necessarily the last one that went in the bag. It could be, but I'm just getting them out of the bag. I don't know what's in the bag. I don't know how to deal with what's in the bag except for pulling them out one at a time and looking at them one at a time. So there is no thing that operates just as a collection. You actually have a list or a set, but the idea of a collection is I don't know what's behind it. I could have a list or I could have a set. If I want something more specific, we'll see when we get to code. I list something more specific. But by listing as a collection, it allows me to work on all of them. You can see some value of this once we start thinking about how we apply this. But the idea is I have this whole world of collections that are out there. You give me one, I can deal with it, whatever actual type it is. The set, as we said, is very similar to the bag concept, except we know inside of the bag there's one and only one of those things. It'd be a really boring game of Scrabble, because at most you'd have 26 tiles inside of there. So if I have A, J, and Z inside of the bag, I add in X, now I have 4 letters. I add in Q, and I have 5 letters. I add in A, that second A does not get added. I stay at 5 letters inside of there. So if I add a second copy, it's ignored. There's a few other things we can know about a set if we go into more detail on the set, but that's the general rule, is I know there's one and only one of each object inside of that set. Now, the list, as we said, is kind of like our train here. We put them in, and we put them in the order they were received. And so typically we add them in on one side and remove them on the other side. But they're 1, 2, 3, 4, 5 going in inside of there. It's a lot of depends on how you deal with it. Again, the ability of the list is I can go to the 7th item and add a new item in. I can go to the 8th item and pull that one out. I can go to the 2nd item and get that one alone, leaving it in place. There's a lot of flexibility in lists, yet the limitations are there could be duplicates inside of there. There's no rules by which how these things are ordered by default, except for the order they're put in. But I can do things like sort them using other tools and things like that. So that's the big 3 that we'll deal with most of the time. I do want to point to map, just so that way you are aware of what it is. The map you can think of as kind of like a list of shelves. I put data on the shelves, and for each shelves, I label that shelf with some information. So I'm staying with the letters as the data that's being stored inside of there. All of these things, I can store anything. I can store letters, I can store bank objects, I can store people objects, I can store numbers, it doesn't matter. But I have some value that goes on the shelf and a different value that acts as a key. The key does not have to be text, it doesn't have to be a number, it can be any object that acts as a key. I can have a list of bicycles on the shelf and a list of people that are the owners of the bicycles on the shelves. That's perfectly reasonable. The rule here, though, is the key must be unique. Each person could own one and only one bicycle, but there could be a bunch of redundant bicycles inside of there. Bicycle, in theory, could be owned by more than one person in that example. Not the best example, but it's not a bad example. And so the way this works is I'm going to go add in the value X. I have that, I don't know, the number 2, fancy number 2 symbol that's going inside of there, and it puts that onto the new shelf that's labeled by number 2. If I go ask for, let's say, the webcam down here, I get back the letter J. That's the way a map works. Okay, so these are each tools that I can use appropriately for my logic. there's not a right or wrong answer. It's entirely up to what you're trying to solve. So we'll see that as we go do some code examples, but this is the set of tools. Let's spend more time diving into them individually so you can understand the specific features and then maybe be able to pick which one you want the best.